number 12 says they give you the coordinates a, negative 3, 2, negative 3, 2, negative 1, 5, 3, negative 4. Okay, so here's my shape. And they want me to reflect it over the x-axis, then translate to the right 3 spaces. Okay, so over the x-axis is right here, so we'll call this point A. So A prime is going to be down 2 spaces. Okay, and then well, this is C. It's going to be down 1, 2, 3, 4 spaces. 1, 2, 3, 4 spaces. Call it C prime. And up here was B, and that's 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. And that's B prime. And I'm going to kind of dash this because this is not going to be the final shape yet. Okay. So then they want me to do that. Then move it 3 spaces to the right. So this goes over here to the 3 spaces. 1, 2, 3. 1, 2, and 3. Okay, it's kind of hard to see because it's got a lot of stuff on here. So if I get a little darker color. And there's my shape. Okay. ABC has been rotated 180 degrees counterclockwise to produce an image. Describe a series of transformation that would produce the same image without rotating. So, kind of trying to get an idea what's going on here. So if I draw a triangle here, okay, so there it is. And if I rotate it 90, it's going to end up like that. And if I rotate it 180, it's going to look like that. So the question is, how do I get there without, and kind of, we'll call this A prime, A double prime. So you can kind of see how that point moves. Okay. Well, how can I get to here without going that same direction? Well, if I reflect it, I'll get A to come down here. So if I reflect it, okay, down here, then translate it over. So I would say reflect over x-axis, then translate. Okay, to the left. Okay. All right. Number 14. Triangle below reflects over each axis. So they want us to name all the congruent parts. What goes with what, or what corresponds with what. So I'm going to say here, angle A goes with angle E. Angle B goes with angle F. Angle C goes with angle D. Okay. For lengths of sides, let me put it up here. So AB is congruent to EF, DF, right? DF and BC, or CB, and ED and AC. All right, these should all be congruent as well. Okay. Are the two angles congruent? So do they have the same size for things that correspond? So you look here, looking at this example, we know that M prime and P prime goes with M and P. So 1, 2, 3, 4, 1, 2, 3, and 4. Okay. 1, 2, 3, 4, 1, 2, 3, 4. So these two sides are the same. Alright, and so using Pythagorean theorem, this side would have to be the same, so that proves it right there. Okay, because MP is congruent to M prime, P prime, and from all the way through that. Okay. Number 16, they want us to translate x plus 3, y minus 4. So that's 3 to the right, 1, 2, 3, and then down 4. 1, 2, 3, 4. So that's A prime. Same thing here. 1, 2, 3. 1, 2, 3, 4.
Campus this morning, T-shirts have arrived. I have small, medium, and large available, and I should be getting another shipment of all sizes by lunchtime today. Stop by Activities to pick up your Bike for Prentice T-shirts.
Yeah, sorry for the interruption there, guys. And there's our new shape. All right, here we go. Last couple, look at number 17. reflect over the x-axis and give the rule. So if you remember, if you reflect over the x-axis, you change the y values to negative. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5. It's B prime, A prime. And draw a shape. In this case, just a line. Rotate 270. So if you remember the rule for 270s, you take each point, switch the x and the y, make the x value negative or change its sign. Alright, so this is going to be a little trickier, so I'm going to list the points. A is negative 4, 3. B is 1, 5. So A prime is going to be, switch them around, change the sign of the x value, the old x value. 5, 1, make that negative, so we're looking at 3, 4, 3, 4. Okay, that would be A prime. B prime is 5, negative 1, and there's B prime right there. There you go.